Okay, good morning, everybody. Just wanted to make sure you know what's going on this week. We're doing this notes today. There's not going to be anything due tomorrow or anything to do tomorrow because of the Cinco de Mayo stuff that the ASB officers are doing. So nothing for Tuesday. Wednesday, we'll have our Zoom session where we do the homework for 12/6. Thursday will be a review day, and we'll have the Chapter 12 test on Friday, which we'll talk more about on Wednesday, but it'll be kind of like the last one, multiple choice, that kind of stuff. So, all right. This video hopefully will be pretty short. I don't think there's anything too complicated in here. Again, it's pretty much like the other stuff that we've been doing. So if you've gotten that, I don't think that this is going to be a problem. We're talking about spheres today, finding the surface area of a sphere. So I'm going to share my screen. Okay, so there's a sphere. Think of it as like a ball or like the globe, that's a sphere, something like that. And so I'm trying to draw one here. Just a couple things that we'll need to know in order to do some of these problems correctly. These circles that I've drawn in here, like that, and that, you can kind of see how those are touching, or they use the center of the sphere, and they're just circles inside of the sphere. Those are called great circles. So if there's a circle inside of a sphere that has the same center as the sphere itself, those are called great circles. So I've drawn two great circles inside of this sphere, and I want you to notice what's important about that is notice the red line here. What do you notice about what this is of the great circle? That line right there, it's a radius of the great circle. It also happens to be obviously a radius of the sphere. So a great circle, since it shares the same center, is going to obviously have the same radius as a sphere since it's coming from the middle. So let's remember that as we do some of the problems today, that the radius of a great circle is the same as a radius of a sphere. Okay, the other thing we need to know is, like, what if I cut a sphere, or what if there's a great circle, or what if I cut a sphere in half? What am I left with? What does, oops, let's not draw it that way, let's draw it this way. What does that look like? That's half of a sphere, right? So what do we call that? What if we cut the globe, the earth, in half? What would that be called? It's a hemisphere, right? Northern hemisphere, southern hemisphere. So if they're talking about finding the area of a hemisphere, we'll just say, okay, that's half of the sphere with one little difference, kind of like when we did something the other day that required us to look at some of those composite figures that we were doing at the end of the last section. But anyway, this half of the sphere would be, of course, called a hemisphere. So put that down in your notes. I'll just leave it there for a second in case you need to stop, but you can pause the video too. So let's find the surface area of some of these things. We'll talk about that in a second, but we also have, like, you can have a plane intersect a sphere like this. I've tried to recreate the drawing on page 714. So this is number 1 on page 714. It has this plane that is plane M that has intersected this sphere. It has a center of A, and you can see that that plane intersects that sphere at point B and point C. So we've just drawn a little right triangle in there, and it tells me in number 1 that AC is 9, BC is 12, and it wants me to find segment AB. So I'm not sure you need to take too much time on this, because this is just a right triangle with 2 sides listed, and find the third side. So when I'm asked to do that, obviously that's just Pythagorean theorem. So real quick on this one, that's just 81 plus 144, C squared. That's 225, and so the square root of 225 should be 15. Yep. So AB in number 1 should be 15. So that's number 1. So you can see if they have this drawing, and we'll do some of these on Wednesday, but they have this triangle form with a plane that intersects a sphere and it makes a right triangle. So what would happen then, and I think the point of this probably is more about like number 2, where it says, if the radius of a sphere is 15 units and the radius of the circle is 10, find AC. So the radius of the sphere, that's obviously AB. So they said that the radius of the sphere is 15. So we'll put that in there. And then the radius of the circle, this plane cut the sphere and formed a circle. And the radius of that circle is, said, 10. So that's CB. So CB is 10. So now find AC. Well, again, that's just Pythagorean theorem, just a little bit different. It's just going to be 10 squared plus AC squared equals the hypotenuse AB squared, so 15 squared. So let's do this out real fast. See what we get. 15 squared, 225. I just did that. I should have known that. Subtract 100. Take the square root of 125. And we get 11.2. So about roughly 11.2. So AC is 11.2, and just doesn't say like inches or anything. So we're rounding to the nearest tenth, it said. So 11.2. All right, number 3. Number 3 says, if Q is a point on circle C and AB is 18, find AQ. So let's say that I've got a point out here, Q, like right there. We'll put it in. And A is a point outside the circle. So let's just draw this like, like pretend that's the circle with the center C, and we say A is out here somewhere. And point Q is also on that circle. Well, in this case, that point, it's like a tangent of a circle. I guess I should draw it maybe this way would help. If I said this is point C and this is point Q, and that's point A out there, what do I know about these two segments, AC and AQ? They're the same. So that's kind of a little review from another section we've had, that if I have a tangent point that is, has two tangents to a circle, they're congruent segments. So AC is congruent to AQ. So since it said that AC is 18, what's AQ? AQ then also has to be 18. So just a little review there, that a point outside of the circle is the same distance to the point of tangency of the circle. Okay. 4, let's do number 4. Now this is where we're gonna have to do kind of some surface area problems. So how do I find the surface area? Well, if you did the geometry lab, which we don't have the foam balls to do all that, and it would take forever anyway, we're just gonna tell you the surface area of a sphere is 4 pi r squared. So basically it's 4 times the area of a circle. So if I was trying to find the surface area of a sphere, if I knew the area of like one of the great circles inside of that sphere, I would just multiply that by 4 and I would have the surface area of the sphere. So, I mean, I know in the other videos I've tried to kind of explain how they got to that, but they explained it in this section by doing a lab, and we're not going to take time to do it. I think I would just put this in my notes right here, and I would definitely highlight that so that I could find it when we do the test on Friday. It should be an H. Surface area of the sphere, 4 times pi times the radius squared. So let's see how that would look doing these problems. Surface area of the sphere or hemisphere, round to the nearest tenth. Number 4, a sphere with a radius of 6.8. Well, we said the surface area of a sphere is 4 pi r squared. So it told me that this sphere has a radius of 6.8. So the surface area is going to be 4 times pi times 6.8 squared. So let's do that on the calculator. 6.8 times 6.8. And then we'll do times 4. and then times that by pi, and round to the nearest tenth, 58.1, or sorry, 581.1, 581.1, and it said inches, so square inches. Okay, pretty straightforward as long as you know that the formula of the surface area of the sphere is 4 pi r squared. Okay, what it says to find the surface area of a hemisphere with the circumference of a great circle of 8 pi. Okay, so this one's a little different. We're going to talk about a hemisphere, so half of the sphere. So we've got something that looks like this, and it says doesn't give me the radius, so I can't really just plug that in. It tells me the circumference of the great circle, which is this part on top, right? That's a great circle based on what we said at the beginning. This yellow area I'm drawing in here. That's a great circle. But it told me that the circumference of that great circle, the distance around that is 8 pi. So it has a circumference of 8 pi. Well, how do I find the circumference? That's just 2 pi r, right? Or the diameter times pi, or 2 times the radius pi. So remember, you should have this from earlier chapters, that to find the circumference, I take 2 times the radius times pi. Well, I know the circumference, they told me. Right there, it's 8 pi. So let's figure out what the radius is of this great circle and the sphere, since they're the same. So 8 pi equals 2 pi r. Let's divide by 2 pi to get r by itself. And I'm left with the radius of this great circle and the sphere is 4. All right, now I can find the surface area of this hemisphere. It's going to be half the sphere added to the area of the circle on the top. So if I just took half the sphere, I would be getting the surface area of half of just what's on the outside. And I need to, since I cut it in half, I now have this top part, the yellow part that I drew in there, that's part of the surface area. So I'm going to need to find the area of that circle that's on top. Think of slicing a ball in half. So I need to find that flat part where I cut it as part of the surface area of a hemisphere. So I'll take half of the sphere's surface area and then add that to the surface area of the circle on top. So let's first find half of the sphere. So a sphere is 4 pi r, and so I'll do half of that, the half out there. What's the radius? We found that to be 4. This should be 4 pi r squared. So 4 is the radius. Let's put this in. Just like that. This is going to give me the surface area of the hemisphere. And so half of 4 is 2. 4 squared is 16. So that's 32 pi. Let's do that on the calculator. 32 times pi. 100.5. So this part, color it different. The green part down here is 100.5. I need to add that to the surface area of that circle. So how do I find the area of the circle? That's pi r squared. So let's add a pi r squared to that 100.5. And since the radius is the same, that's 16 pi. So the radius was 4. So we'll do 16 pi and get 50.3. 50.3. Add that to my 100.5. And I get 150.8. And this one is centimeters. Okay, so that's the surface area of that hemisphere. The green part, which is half of the whole sphere, plus the surface area of that orange part that I filled in. So let's do one more. Let's do number 5 or 6. We're on 6 as an example. Surface area of a great circle Find the surface area of a sphere with the area of a great circle approximately 18.1 square meters. Okay, so I have a sphere like that, and it has told me a great circle that has an area of 18.1 square meters. So the area of that circle inside here, this great circle, is 18.1 square meters. So let's figure out then, how am I going to know what the radius of that great circle is, which would also be the radius of the sphere, which is what I need to find the surface area. Remember, surface area of a sphere is 4 pi r squared. So I need to find that radius somehow. Well, it told me the area of that circle, is, what did it say? It's 18.1. So 18.1, we can solve for r that way, right? If I say pi r squared is equal to 18.1, so let's solve for r. So let's divide by pi and get 18.1 divided by pi should give me r squared. Do that on the calculator. 18.1 divided by pi. I get 5.76, something like that. But I'm going to end up, I need to take the square root of that. So I get the square root of 18.1 over pi should give me r. So let's take the square root of that. And I get 2.4. So the radius is 2.4. Now it's going to be simple to find the surface area of the sphere. Just put in 2.4 for the radius. So let's square that 2.4. And let's multiply it by 4. And then multiply it by pi. And get 72.4 meters squared. Okay, so like I said, as long as you know what the formula is to find the surface area of a sphere, which is 4 pi r squared, I think you should be able to do most of these questions, especially if you remember that a great circle has the same radius as the square. And then you can kind of use like other information that we've had up until this point to maybe find the radius when it gives me like the circumference of that great circle or the area of that great circle, something like that. So take these notes down, put them in your OneNote or attach them to the assignment. And then we will meet on Monday, or sorry, we'll meet on Wednesday to go over the homework problems. Okay, I'll post the homework on Tuesday. So if you wanted to do some of the problems Tuesday, you could, but you can wait till Wednesday to do that. All right, have a good day. See ya.